Alright, so I think this is recording. We're taking a look at skill packet 5, which is exponential and logarithmic functions, and here in this homework set, which I've already forgotten the letter, I think it's G. Yeah, in G, we're solving exponential and log equations, and so here I have an exponential. I don't have any properties of equality that's going to isolate the x, and that's what I need to do. But I can use properties of logarithms and take the log of each side and use the power rule to begin to try to get that variable by itself. If I'm going to use a calculator to later approximate my answer, then I'll either want to use the natural log or the common log when I take the log of both sides. It doesn't really matter which one we use. And in years past, students always tell me to use the common log. Almost always that I can remember, I always use the natural log in my solutions, but it doesn't matter. It was just that I was used to doing it that way. Alright, so if I take the log of each side, what does that do for me? Well, like I say, because the power rule now, I can take this 0.4x and move it down as a coefficient. So I've got 0.4x that's being multiplied by this number, this common log of 8, and that's equal to this common log of 5. So to get the x by itself, since this is all multiplication, I need to divide these other factors. I need to divide both sides by 0.4 log of 8. And so 0.4 divided by 0.4 is 1, and log of 8 divided by log of 8 is 1. And so I have that x is equal to this common log of 5, and in the denominator I have 0.4 times the log of 8. And it's not going to gain me anything to take that 0.4 and raise it up as an exponent. I don't see any true benefit of doing that off the top of my head. So I'm going to leave that as my exact answer, and my decimal approximation, I can jump into a calculator, a scientific calculator, take the log of 5, close that parenthesis. Now, around the denominator, I need parentheses around it because I don't want to divide it by just 0.4, but I need to multiply it by 0.4 times the log of 8. Close that parenthesis with 8, and then I'll close the parenthesis for the denominator, and now I get to 3 decimals, 1.935, if I haven't made any silly type of errors. If we come back to the original equation and take 8 and raise it to 0.4 times our approximation, 1.935, we won't get exactly 5, but we should get pretty close to 5. Well, in that case, it did, I'll bet you if we took it to more decimal points, it wouldn't be exactly 5. Let's just float it and see. Yeah, see, it wasn't exactly 5, but close. Alright. This was the exact value. This is an approximation. It's a very good approximation. Alright, so let's take a look then at number 12. We've got two terms on the left-hand side. The first term contains our variable of interest. We need to get that by itself. So we've got this negative x over 10. If I subtract 8 from both sides, I get 7. Well, I can't rewrite this 6 with a base of 7, so I'm going to have to take the log of each side and use properties of logarithms. If I take the common log of the left-hand side, then to balance the equation, I have to take the common log of the right-hand side. By the power rule, this exponent comes down as a multiplier, and I have x over 10 times, and since I'm just going to put it in the numerator, times the log of 6 is equal to log of 7. Alright. So to get the x by itself, I'm going to multiply both sides of the equation by the reciprocal of these other factors. So I need the 10 in the numerator, the log 6, and I also need to make it negative. So if I'm multiplying that on the left-hand side, I need to multiply this on the right-hand side. So now this, well, the negative times negative is positive. 10 divided by 10 is 1. Log of 6 divided by log of 6 is 1. The negative times negative is positive, so I have x. On the right-hand side, let's put that negative 10 as a multiplier in front of the log of 7. And 1 times log of 6 is just log of 6. So I claim that if we punch this into a calculator, we'll get a decimal approximation. Let's see what that is. I'll need parentheses around this numerator. I've got negative 10 times the log of 7. I said I needed parentheses and I forgot to put it in there. And then divided by the log of 6. Alright, so I've got negative 10.86. Oh, I forgot to round it to 3 decimals, didn't I? So I can do that myself. And let's plug it in and check and see on the left-hand side when we plug it in if we do get approximately 15. So I've got 6 raised to the opposite of my answer. Well, the opposite of negative is a positive. Divided by 10. I guess I could have moved the decimal myself. Then I have to bring it out of the exponentiate and then go plus 8. So that's real close to 15. So hey, that's my answer to 3 decimals. All right, so I hope that helps. Talk to you later.